So, welcome back, students. In our last lecture, we have completed our exercise number 3, and today we are going to start our NCERT exercise. And hopefully, in 2 or maximum 3 videos, I will try to cover this exercise, and I will also try to explain you that how you are going to solve this question, and you are also free to do it yourself. Then after doing it, you can match them with the solutions I provide, and hopefully you also will be getting the right answers, and at least even more important, that you will be getting a better understanding that why that particular answer is here and what is the route to getting it. So let us start with question number 1. Here on your screen you can see question number 1, and it's also available in your NCERT book if you have, and these books can also be downloaded from internet. You can just search on Google NCERT books download, then it will guide you to NCERT website, and from there you can download a whole book or chapter wise depending upon your class after selecting your class. So let's cover our question number 1. Let me adjust pen width, it's slightly thicker, still thicker. Yeah, it's okay now. So here are some activities are listed, and we have to find out that we are doing work or not in those activities. Okay, so in our understanding, what is work? In our understanding, work is force into displacement into cause of that angle between force and displacement. So for work to be there, we need force and displacement. Both these things needs to be there, and theta must not be 90 or 270 degree. Just focus here on a 90 degree. So theta should not be 90 degree. So direction of applied force and displacement should be similar or close to similar. They should not be perpendicular. So here Suma is swimming in a pond. So suppose this is a pond. Suppose this is water. This is stream of water. And if a person is swimming, suppose this is a person who is swimming in a forward direction. So when he swims, what he do? He pulls this water in backward direction, like this. When he pulls water in a backward direction, that water applies a forward force in him, and that's why that person moves forward. So the force applied by what person is backward. The person applies a backward force. He pushes water backward, and his displacement is in forward direction. Okay, so there here theta is 180 degree. Force is in backward, applied force is backward, and displacement is forward direction. So theta is 180 degree. So work will be negative, but there will be work. So this is work by person is negative because he is applying force in backward direction. And if force is similar, if we consider work by water, because water is applying force in forward direction and displacement is also in forward direction, so work by water is positive. Okay, so whenever there is a work, it has a positive part and negative part. Positive part by one object, second negative by another. I will give you another example. Suppose this is ground and object was in starting in at ground, now it is at height h. So how much work is done? mgh on object. This work is done on object, so it is positive, but it is by done whom? It is done by gravity, and by gravity is minus gh. Gravity has lost that much energy, and that energy is gained by object in form of its height. So that person that trying to swim, he loses some energy because he's doing work, so he's losing energy, so his work done is negative. Okay, and in the form of that he gains a displacement by when he applies force on water, that water again pushes him in the forward direction. Okay, so there will be work done. When person is swimming in the pond, work done will be there. Now a donkey is carrying load in on his back. So let me clear the screen. Donkey is carrying the workload, carrying the load on his back. So suppose this is donkey. Okay, he is carrying load on his back. This is the load on back of donkey. So to keep this load in its place, what he has to do? He has to apply a upward force because the mass of that load is acting downward. Mg is acting downward, so he has to apply an upward force. But when donkey is moving, displacement is in either this or this direction. Means force is upward and displacement here, force in y direction. Applied force by donkey is upward, so it is in y direction, and displacement is in x direction. Okay, so theta is 90 degree, and if theta is 90 degree, then work done is 0. There will not be any work done by donkey. Okay, moving to next question, next part, sorry, part number 3. A windmill is lifting the water from the well. So suppose this is windmill, it is like something this, and we have buckets here. Buckets are attached to this. When it rotates, let me explain how it happens. Wind strikes here. Wind strikes here, due to which it rotates like this. And here is water. It is a pool. Here is water. So when it rotates, it carries water in these buckets, and that water rises. Okay, so here we have to find out that is there any work done. So it depends, because suppose some water was here, this water was here, it rotates, the windmill rotates and water reaches here, so its displacement is in vertical direction. Okay, but the force was acting due to wind, that is in horizontal direction. So force is acting like this. So the angle between both of these, this is force and this is displacement. Angle is 90 degree. So if angle is 90 degree, then work done is 0 by force applied on by the wind. It's only technically 0 because we are transforming here the force. With the help of this circular shape structure, we are transforming the force into rotational force. So there will be work, but that will be another type of work due to torque. So if you just consider by this simple phenomenon that force is acting on this direction and displacement is on this, there is work. There is no work. But if you once you study rotational mechanics, then there is torque and there is displacement. Then so there will be work depending upon the rotation. So if you just simply consider what you have studied, according to that there is no work. But in actual there will be work, and that work depends upon the amount of torque applied on this rotational system and amount of theta displacement, the how much angle is covered, because this is a rotational system. Okay. Now going to part number 4, a green plant carrying out photosynthesis. So when plant, suppose this is plant, these are the leaves of plant. When they are carrying photosynthesis, so in visible form, means what is visible to us, these plants will not move. They carry photosynthesis at their place. They don't move during the photosynthesis. So there is no displacement externally. And as there is no displacement externally, so there is no work externally. But internally, there is chemical reaction happening. And due to those chemical reactions, ions are getting displaced. So internally, there is work. But if you are just looking externally, there is no work. Okay. Last is an engine is pulling a train. So suppose this is an engine and these are its bogies. So when engine pulls train in forward direction, displacement is also in forward direction. This is force, this is displacement. Angle is 0. So there is work done. So in first part there is work done. In second note, in third note, in fourth note, in fifth there is work done. And one point more, you can get different answer for all of these depending upon the author you are following. Okay, like this for this windmill, there will be work because there is torque acting on it and there is theta displacement. So there is work depending upon the which situation he has considered. The answer will vary. Like for this also, for photosynthesis, if we look externally, there is no displacement, so there will not be work done. But internally, photosynthesis is a internal process, and during chemical reactions, displacements of ion happens. There is transformation of energy from sunlight to chemical energy. So there is work done is going on. So it depends upon how you look at certain thing, and your answer can vary depending upon that. Now we're going to it's one there are two more parts related to this question. One is food grains are getting dried in the sun. So when food grains are getting dried, they are uh, they are just still, they are just staying there. What is only happening? Evaporation of water is happening from them, but displacement is 0. So work done is 0. Other part is a sailboat is moving due to wind energy. So suppose this is boat and here is a sail attached to it. So when wind acts on it, wind applies a forward force on it, due to which there is forward displacement. So force is there, displacement is there, so work is there. Okay. So now let's move to question number 3. Sorry, 2. A object thrown at certain angle to the ground moves in curved path and falls back to the ground. The initial and final points of the object lie on the same horizontal line. What is the work done by the force of gravity on the object? So here it is mentioned that suppose this is ground. Suppose this is ground. Let me draw its path. So objects moved like something like this. So it is mentioned that it was thrown at certain angle. So suppose angle is theta. It was thrown with angle theta from the ground. Okay. It moves a curved path. This is the curved path and fall back on the ground. Suppose it was thrown from point A and it falls back at point B. Now both points are on the same ground, means at same level. Okay. Now we have to find out that what is the work done by the force of gravity on the object. So here you can have two different routes or two different methods of doing this question or solving this question. First, as I already explained to you, that work done only depends upon initial and final condition, not on the path. Okay, so here initial condition is A and final condition is B. And what type of movement is there? There is vertical movement, as object was moving in y direction, so there is vertical movement, and there is horizontal movement also. As object is moved from A to B, those points are horizontally separated. So first we will look for the vertical movement. From there we will find the work done, and then we will look for horizontal movement. There we will find the work done. Now, as I already explained, whenever there is vertical movement, then work done is equal to change in potential energy. Okay. Now change in potential energy is formalized mgh, mass into gravity into height. Now both point A and B are at same height. So as both of they are same height, that potential energy change is zero. The energy at A is zero and the energy at B is zero, because both of the points are on ground, and on ground we consider potential energy as zero. So change in potential energy is also zero. So due to vertical, the work is zero. Now consider due to horizontal movement. Now horizontal movement, in work we see kinetic energy, change in kinetic energy. So when object was thrown, it had certain velocity, suppose v here. When it comes back at point B, it will have the same velocity, just direction will be changed. Here direction was in from the up of the ground, Here direction will be towards the downward movement. But in kinetic energy, as we have square, so direction does not matter. We just have to find the change in kinetic energy. And the kinetic energy at point A is same at kinetic energy at B. So change in kinetic energy is also 0. So work done due to both vertical and horizontal movement is 0. So total work done is also 0, or work done by gravity is also 0. This is the one method. Now I will show you another method by which you can calculate, and answer will again be 0. Let us draw again. Suppose this is ground. And this is path. What is happening here? Let me choose different color. It is the path of the particle. Suppose this is the height, maximum height that particle has achieved. Now we can say here it is point A, point B, point C. So particle moved from point A to point B, from point B to point C. Here particle had some velocity, that is v, that is in upward direction. Here particle has some velocity, that is v, that is in downward direction. Okay. So when particle moved A to B, then work done by gravity will be negative, as gravity is act in downward direction and displacement is in upward direction. And work, as there is only vertical movement, A to B is vertical movement. So what will be the work done? Minus mg, sorry, work done by gravity is mgh. Here we can say work done by gravity is minus mgh, and work done on particle is mgh. You just have to remember the signs, because object is going upward, so its energy is increasing, so there is positive work done on it, and that work done is done by some force. That force is gravity. It is losing energy and particle is gaining energy. So gravity has lost some energy, that is minus mgh, when particle went from A to B. Now particle again reverses the direction and comes B to C. So when particle comes B to C, now gravity is also downward and displacement is also downward. Okay, now both are in same direction. So from B to C, work done by gravity is mgh. Now sign has changed. Now total work done by gravity is sum of both of these. So minus mgh plus mgh, answer comes out to be 0. Here we are not considering this horizontal movement, because we are in question, we have been asked to only find out the work done by gravity. In the question, work done by force of gravity, and gravity is a vertical force. So we will look only into vertical movement. So net vertical displacement is 0. From that you can also find out that work done is 0. Now moving to question number 3. A battery lights a bulb. Describe the energy changes involved in the process. So here we have battery, and battery to we light up a bulb. Now battery has what type of energy? In starting, battery has chemical energy. That chemical energy gets converted into electrical energy. Then that energy flows through wires, comes to bulb, and gets converted into light energy plus heat energy, because bulb also get heated during when it's working. So this is a transformation: chemical to electrical, and electrical to light plus heat. And actually, from chemical to electrical there is also heat, because when that converted electrical energy moves through wire, some of that it gets converted into heat. That's why wires gets heated, and that only that part of electrical energy get converted into light plus heat energy. So if we draw a block diagram, we can draw the like this. In starting we have chemical energy. It gets converted into two parts: electrical energy plus heat energy. This heat energy get lost. Now covering this electrical energy, we convert that electrical energy into two parts: light energy, which we can see, and again heat energy, that bulbs get heated. Okay, so in form of number, suppose this was 100, this is normally 95 and 5, and out of 95 again 5 or 6 is there and 90 is there. So if we put 100 joule of energy, we get only 90 joule of work, actual useful output. That's why efficiency is less than 1, and efficiency is never 100%. So going to question number 4. Certain force acting on 20 kg mass changes its velocity from 5 to 2 meter per second. So here mass is mentioned as 20 kg. Starting velocity is 5 meter per second. Final velocity is 2 meter per second. We have to find out the work done by the force. So as we know, if object is moving, there is some object that is moving, it must be moving horizontally. Suppose in starting object was at this position, or position A, and after some time object has position B. At A its velocity is 5, at B its velocity is 2. So object is moving horizontally, so there is horizontal movement. And if there is horizontal movement, then it means work done is equal to change in kinetic energy. If there is vertical movement, then work done is equal to change in potential energy. If there is horizontal movement, then work done is equal to change in kinetic energy. So change in kinetic energy is equal to final kinetic energy minus initial kinetic energy. If that object has been stopped, we will finding initial kinetic energy, because final kinetic energy will have gone to 0. But as object has not been stopped, so we will be finding their differences. We will find out the final minus initial. Now formula for both are same: half m v final square, half m v initial square. Now what are mass? Mass is 20. So mass is 20, Final velocity is 2, that's half 20. Final starting velocity was 5. Okay, so calculating this, 440 minus 10, 25, 250. So work done is minus 210 joules, and this is work done on car. Work done on car is negative, means if it is negative, it means that it implies that energy of car is reducing. Okay, energy of car is reducing, and so its velocity is also reducing, which we can see that final velocity is 2 and starting velocity is 5. If it has been positive, then energy should be what? Increasing. And if energy increasing, that means velocity should also be increasing. Okay, move to next question. Question number 5. A mass of 10 kg is a point at a point A on table. Suppose this is table and this is point A and this is 10 kg mass. It moved to a point B if the line joining A and B is horizontal. It moved to this point B, okay, and line is horizontal. Okay, so if for horizontal, we are talking about change in kinetic energy. What is the work done on the object by the gravitational force? Explain your answer. Now we have to find work done by gravitational force. Now gravitational force act in upward direction, or actually downward direction. Or we can say in y direction. So gravitational force act like this. Gravitational force is acting in this direction. So force is in this direction and displacement is happening like this. So displacement is like this. So displacement is in horizontal, force is in vertical, or minus y. Angle is 90 degree. So if theta is 90 degree, what is work? Work's formula is force into displacement into cos of theta. And if theta is 90, cos 90 is 0. So work is 0. You just have to see direction of force and then direction of displacement. From that you can find out that is there, if there is any type of work or not. Coming to question number 6. Potential energy of freely falling object decreases progressively. Does thus violate law of conservation of energy? So let me draw here. Suppose this is ground. I will draw all three cases. So case number 1, case number 2, case number 3. This we have already proved. Suppose in starting object is here. Okay. So let us consider in starting object is at some certain height, and that height is h. Now let us draw it over. After some time that object is reached here. Suppose this is height is s, and after some time the object has reached at ground. Okay, so in question it has been asked that if object is falling, its potential energy is decreasing, and if its potential energy is decreasing, so does it means that there is violation is happening of law of conservation of energy. So here object has zero velocity, here object has some velocity, suppose velocity is v is equal to v1, and here object has some velocity, suppose v is equal to v2. Here height is 0 because object has touched the ground, so height is 0. Now we know that at this, at, so suppose at place A, B and C, in case A, object has what, only potential energy because velocity is 0, so its total energy is equal to mgh, that is only it has, as it has only potential energy, so its total energy is equal to mgh. And in case of C, it has only kinetic energy as its height is 0. So due to its height is 0, so there will be no potential energy, and if there is no potential energy, it means there will be only kinetic energy, so its total energy is equal to half mv2 square. Okay, now we will not solve for case B, as we have already solved this in our theory class, so you can visit our previous videos for seeing this complete solution where we have solved for A, B and C case. Now I will be solving for case number C. Now we have to find this velocity. Now we know that starting velocity is 0 and v2 is our final velocity that we have to calculate, and we know height is h, so displacement is h, and acceleration is minus g, and displacement is also negative as object is coming downwards. So if we use this equation, v square minus u square is equal to 2as, this is our actual equation. So v square minus u square is 0, so u square is 0, 2, acceleration is minus g, and displacement is minus h. So from this we get v square is equal to 2gh. Now we put this value of v square into total energy, this formula of total energy, half m, v2's value is 2gh, v2 square is value is 2gh, so it comes out to be mgh. So our total energy remains constant. Due to this, there is no violation of law of conservation of energy. Energy just changing between potential energy to kinetic energy. There is only transformation happening between potential energy to kinetic energy. There is neither any loss of kinetic energy nor any gain of kinetic energy. So that's why law of conservation of energy holds, and only transformation of energy is happening. So till now we have covered up to question number 6, and in next video we will go further and will cover remaining questions. And if this video is helpful to you anyhow in clearing out your concepts, then please like, share and subscribe. Thank you.